5, 17, 16. And this is help and hints on the chapter 20, the circuit homework for physics. So which ones do we need help with?
It's number 2 on
Number 2 on 739. Okay. So number 2 on 20A practice, and it's part C?
Yes.
Okay.
I was able to get everything else but that.
Perfect. Okay, so we're given this circuit. This has got a 24-volt battery. And we've got a 4-ohm resistor, 8-ohm resistor, and a 12-ohm resistor. First thing we're asked is to find the equivalent resistance of the circuit. They're in series, so it's just additive. So that's pretty easy, and I think everybody got that easily. So what you end up with for the equivalent resistance of the circuit is 24 ohms. Fantastic. What's the current in the circuit? Well, this is where you have to go back to remembering the video, and we had twinkle, twinkle, little star, V is equal to IR. So we have the voltage, we have the resistance, we want the current, I. Okay, so we're solving for I, V divided by R gives us I. So pretty easy, 24 volts divided by 24 ohms, we get 1.0 amps in the circuit. Now, here's the interesting part. Because this circuit has all the resistors in series, the question that you want to ask yourself is this. Is there more than one place that current can travel in this circuit? Is there more than one path for the circuit to travel in? So that 1 amp has to go through here, it has to go through here, and it has to go through here. So, yes. So every resistor, no matter what its resistance is, gets the same amount of current through it, because when they're in series, the current through each individual component is the same as the current through the entire circuit. Now, if this were something that was done in parallel, so if we had a setup like this, and we had two different resistors, a 2-ohm and a 4-ohm resistor, the current through these would not be the same, because electrons, the flow of electricity, can go this way or it can go this way, and different amounts are going to flow through each portion of the circuit based on how much resistance to flow there is in that portion of the circuit. Yes, ma'am. You can do this one. Let's make this a 9-volt battery. So first of all, we need to figure out the equivalent resistance of the whole circuit. So in this case, 1 over R equivalent equals 1 over R1 plus 1 over R2. Okay, so we get an equivalent resistance of 1.3 ohms. With series, the equivalent resistance is always lower than, so if you only have 10 ohm resistors and you need less than 10 ohms of resistance, what you're looking at is how to hook them up in parallel, rather, because you'll have less resistance in parallel than you would in any individual one of them. Okay, so now we have the equivalent resistance, we have the voltage. What is the current in the whole circuit? So V divided by R equals I. 9.0 volts divided by 1.3 ohms. We get 9 divided by that, 6.75.
1.3 ohms. I put 1 over 2 plus 1 over 4, and I got 0.75.
That's the reciprocal. 1 over equivalent resistance equals 1 over R1 plus 1 over R2. So take the reciprocal of that, you're going to get 1.3.
Okay.
Got it?
Yeah.
Got it. Thank you.
Okay, no problem.
I'm still complete.
Okay. So and it would be 6.8 with sig figs. So 6.8 amps in the entire circuit. Now for the question of how much current is flowing through each of those. So we know there's 6.8 amps in the whole circuit. Look at this, darn it. Okay, so we got raw numbers for our current through resistor 1 and resistor 2. If you remember that the raw number for the total current in the circuit was 6.75, the sum of the currents that are going through those resistors should equal the sum of your total, and they do. And that's just because that's how much current you have flowing in the circuit. some of it's going to go through one resistor, some of it's going to go through another. The amount of current that flows through the two resistors, when you add it together, should total the current in the total circuit. Does that make sense? Okay. This is some help and hints on number 5 on 739. So you're given a circuit with a 4.5 volt battery, 7 ohm resistor, and this mystery resistor. We don't know what it is, but we're told that the current through the entire circuit is 0.60 amps. So, can you figure out the equivalent resistance of the circuit? Well, yeah, if you have the total voltage, the total potential difference, and you have the total current, you can figure out the equivalent resistance of the circuit. Well, what do you know? These are in series, so from the equivalent resistance of the circuit and the resistance of one resistor, can you figure out the resistance of the other? Of course you can. And this is some help and hints on number 2 on page 744, 20B. So you're told that you have a length of wire that gets cut into 5 equal pieces. So we put them all in parallel, and we're asked to find what the resistance of the original piece of wire was before we chopped it all up. So the equivalent resistance of this circuit, we're told, is 2 ohms. So to find this, we need to know that 1 over R equivalent equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R5. Well, that's great, except these are all identical, which means we can simplify that tremendously and say that 1 over R equivalent is equal to 5 times 1 over R1. Okay, great. Now, can you rearrange that to solve for R1? Of course you can. And once you have the resistance of one of these pieces, can you figure out what the equivalent resistance was when all 5 of them were hooked together in one single piece of wire? Yes, you can. Alright, so this is number 4 on 20B, page 744. So you've got some unknown voltage from a source, an 18, a 9, and a 6 ohm resistor wired in parallel. They tell you that there are 4 amps going through the 9 ohm resistor. First question is equivalent resistance. That one's pretty easy. For B, what is the voltage on this source? So all they're asking is what's the voltage in this battery. So the easiest way to find that out, if you remember how you figured out the current flowing through an individual resistor, twinkle, twinkle, little star, V is equal to IR. So we've got the current and we've got the resistance, so the voltage from the source should be what? 9 times 4. So that'll give you the voltage on the potential source, and then you can go ahead and calculate, once you know the voltage on the battery, basically, you can calculate the current in the other resistors. If you have more questions, come see Moser.